Section 3.5, polygons. First thing that we need to do is talk about the two different types of polygons. First one is called a convex polygon. Polygon means many-sided figure. And a convex polygon is a shape where all the diagonals are inside the polygon. Diagonals are the lines that connect all of the vertices, plural of vertex. A concave polygon is a shape where some or part of the diagonals are outside of the polygon. Think a cave, you're going inside, and notice that it goes inside from vertex to vertex. You have some parts that are going in. I call it an innie. Into how many triangles can these polygons be divided? Here's what I'd like you to do. Please copy these 4 polygons into your notes and then draw a line, a diagonal, from one vertex to another vertex where you are creating triangles with none of the diagonals overlapping. Pause the video and do the drawing. Your drawing should look something like this. I was able to divide the different polygons into separate triangular areas. Notice that this 6-sided shape has 4 separate triangles. This 4-sided shape has 2 separate triangles. And this 5-sided shape has 3 separate triangles. This becomes very important. If you take a look at this hexagon, 6-sided figure, the number of sides, n sides, n equals 6. If you were to divide this into the number of triangles without any diagonals overlapping, you would see that we have 4 triangles. You were just given a theorem yesterday about the sum of the angles of the measures of a triangle. So tell me, if you have those 4 triangles, what would the measure be of the interior angles of that entire hexagon? You have 4 separate triangles. They're each 180 degrees. The total number of degrees inside that hexagon is 720 degrees. If we wanted to create a formula that would allow us to find out the sum of the measures of the angles of a polygon, we would take the number of sides that it has, and we would subtract 2 from it, and we would get the measure of the triangle. So we'd multiply times 180. So here's our formula. The formula to find the sum of the interior angles is n, being the number of sides, minus 2 times 180. That becomes our theorem. The sum of the measures of the angles of a convex polygon with n sides is the quantity n minus 2 times 180 degrees. We found on the last page that the sum of the measures of the angles of a hexagon is 720 degrees. If it's a regular hexagon, what's the measure of each interior angle? We need to recall that the word regular means that every angle is the same and all the sides are also congruent. So find out what the measure of each interior angle would be if the sum is 720. Each interior angle would be 120 degrees. If the measure of each interior angle is 120 degrees, what's the measure of each exterior angle? 1 at each vertex. If I extend each side 1 at each vertex, I would create the picture that you see. So if one of the interior angles is 120 degrees, what would the measure of the outside angle be? Using the linear pair postulate, you can find that the measure of the outside angle is 60 degrees. Now remember, there's one exterior angle at every single vertex. So what is the sum of the measures of the exterior angles of this particular polygon? If I were to tell you that this is a square with all right angles, what would be the sum of the exterior angles? You'll notice that even for a square, a 4-sided figure, we get the same total degrees that we do when we did a hexagon. So we now have another theorem. The sum of the measures of the exterior angles of any convex polygon is 360 degrees. Here's a tricky problem. If I tell you that the interior measure is 160 degrees, can you tell me how many sides there are in this regular polygon? Think back to what we just did with the exterior measures all having to be 360 degrees, and see if you can figure out how many sides this particular shape would have. If you said that the measure of the outside angle is 20 degrees, and we know that 360 degrees divided by 20 is 18, then we would know that there are 18 sides in this particular polygon. Please finish up your note sheet and have questions ready for tomorrow.